Hi students, Ms. Slyman here. I just wanted to talk about a few of these to make sure that we're all on the same page. So if you're super comfortable with logs, then maybe you can look at that first problem and just immediately see that x is the same as log base 2 of 5. But if you don't immediately see that, let's look at the algebra behind it. So I know that I don't want to have an exponent of a variable. I know that if I have a log though, one of my log rules is to move the exponent in front. So I can pick any base that I want when I log both sides, and I'm going to pick log base 2, and there's a reason for that. So I'm going to pick log base 2, and I'm going to do log base 2 on both sides. So now this x comes in front, and I'm left with log base 2 of 2 equals x log base 2 of 2 equals log base 2 of 5. But the reason I picked the base of 2 is because log base 2 of 2 is just 1. Remember, this is saying 2 to what power is 2? Well, it's just 1, so I'm left with with x equals log base 2 of 5, which is what I had originally stated here. Now this one I could do the same idea. I could start by saying log base 5 on both sides, but instead, I'm first going to try to isolate the k. So I'm going to rewrite that as 5k. Of course, I could write it as 5k times 5 to the negative 2, or I could say divided by 5 squared, because a negative exponent I can rewrite in the opposite place, so in this case in the denominator, that's equal to 3. I'm trying to isolate the k, so I'm going to multiply 5 squared on the other side. Of course, 5 squared is 25, so I get 5k equals 75. And now I can do log base 5 of both sides to get k equals log base 5 of 75. Remember, when I log base 5 over here, k comes in front. Log base 5 of 5 is just 1, leaving me just the k. All right, so I'll leave you to do this one. And I'm going to come down here and just sort of talk you through this. I would add 4, then I would divide by 2, then I would rewrite this as 3 to the m divided by 3, etc., etc. The one that I think is really interesting, though, are these two down here. And these two down here, I see trinomials. This one's a trinomial because I can move this to the other side. And I also see e to the x squared minus 3e to the x plus 2 equals 0. This is a quadratic. So I can either do a u substitution, or I can just see it as this thing squared minus 3 of that thing plus 2. Well, that's going to factor as e to the x minus 2 times e to the x minus 1 equals 0. E to the x is 2. So in this case, the base I'm going to choose is e. Instead of writing log base e, that's of course just ln. So x equals ln 2. E to the x equals 1. Well, that means that x has to be 0. Again, hidden quadratic. I've got e to the x squared plus e to the x minus 6 equals 0. So e to the x plus 3 times e to the x minus 2 equals 0. E to the x equals negative 3. That's never true. That has no solution. E to the x equals 2. Well, we just saw that over here. That means that x is ln of 2. So down here you can see that I've started this one. I broke up my 3 to the x plus 4, called it 3 to the x times 3 to the 4th, and I'm going to isolate my x. So I'm going to write this as 6 divided by 3 to the power x, because 6 to the x divided by 3 to the x is the same as 6 over 3 to the x equals 3 to the 4th. I'm not going to expand this to 81 because I see that I have a constant in front. To get a constant in front, when I log both sides, I need an exponent. So I'm leaving my exponent there. This is, of course, just 2 to the x. It says that I want ln, so I'm going to ln both sides. So ln of 2 to the x equals ln of 3 to the 4. Bring my x in front, and then divide the ln of 2 to the other side. So I'll have ln of 3 to the 4th. I'm going to move that 4 to the front, divide by ln of 2. And there's my final answer. All right, so you continue. I would like you to solve examples 6 and 7. Check your answer with your calculator. You can do that on both of those, and we'll talk about them more in class.